Cross-cutting concepts are an important part of science. These are the concepts and ideas that we see throughout all topics of science. They help us connect scientific ideas and topics and help scientists develop a better understanding of the world. So, by understanding how all these topics are related, means understanding the nature of science itself. And without this understanding, science would just be a collection of random facts, random experiments, random experiences. To help scientists see this big picture, they notice these seven concepts that are spread out through all of science. And when we start talking about these, you may notice that you've seen these things before as well. Looking at these seven concepts, it's helping communicate a scientific way of thinking about a topic. I like to think about this kind of like a game, and I try to think about different science topics like chemistry, dinosaurs, anything, and see if I can come up with any of these cross cutting concepts, see if they're related to that topic I'm thinking of. So, for example, if I was thinking about dinosaurs, I'm picturing the T Rex and I'm picturing those little tiny hands the T Rex has. That's a structure. Then I'm thinking about what is the function of those little hands? They're there for something. They did something. They didn't, they always look to me like they don't reach the Tyrannosaurus Rex's mouth, but they do have some sort of function. Let's think about these cross cutting concepts. The first one that I always see in science are patterns. Patterns are something we see all the time. We see it in science, we see it in other subjects too. When we see patterns in places we don't expect, that's when we start to ask questions. Why is that pattern there? What does that pattern mean? Another cross cutting concept we see very often is cause and effect. So events have causes. Sometimes they're simple, sometimes they're not so simple. Figuring out why and what's causing that effect, it's a big part of science. I have this picture here that shows us what's going on when someone touches something hot. So if someone touches something hot, a signal is sent along the nerves in your hand, up to your arm, up to the spinal cord, up to the brain, and your brain sends a signal back to the arm that tells the hand to move the hand away. Stop touching that hot object. That's a cause and effect. The cause is you touch something hot. The effect is with all that, those nerves and everything, you pull your hand away. This happens in many different areas in science. Another cross-cutting concept is system and system models. We see this all the time. System is some kind of organized group of objects or components. Models can be used to help us understand this system better. So we have our water cycle here. This is a system. We have a model of it in this picture to help us understand the water cycle better. A system could even be the galaxy, something really big. That's a system, or something as small as the human body or an elephant. These are systems as well. Another cross cutting concept we see often is structure and function. These are two things that go together. The way an object is shaped or structured determines its function. So I have this bicycle here. This bicycle has many structures to it, and each of those structures have a function. So if we look at the wheel's a structure. The function is to make the bike go, to make the bike be able to move. Then even thinking about the tire itself is another structure. The function is it makes the bike ride a little bit more smoothly. Another cross cutting concept is stability and change. Stability is the idea of staying stable, fixed, unchanged. Our body is an example of this. Our body is always trying to remain stable. So, for example, I have this picture of someone sweating. When you get hot, you sweat. So your body goes back to that cooler temperature, that stable temperature where it had been. Another cross cutting concept we're going to see very often, again, I'm just giving you a simple example, is energy and matter. We see energy through so many different areas of science. Just something, a simple way that I'm thinking about what I had for breakfast. I had a strawberry. A strawberry's matter. It's something that took up space. I ate that strawberry and then my body converted it to energy. Energy doesn't just have to be something with I shouldn't say with movement, but energy isn't just something with our body. Energy could be energy of heat. So fire, energy could be electrical energy or magnetic. So energy is throughout science. And you can think about how many different times you've heard that in the past science that you've learned. Finally, the seventh cross cutting concept, scale, proportion, and quantity. Scale is helping us understand science so much better because science could be really, really big or really, really small. So, for example, on the right of this page, I have these two pictures. Can you guess what these are? This is a snowflake, but it's really, really zoomed in. We would never see these details of the snowflake with our own eyes. We also can't really understand how big this snowflake is now that it is magnified. So they have a scale here to help us understand that a little bit better. And we can see this picture here with looking at a human hand. Scale is helping us visualize things better. Think about if we're learning about space, how far away the moon is, how far away the sun is. Those ideas are very difficult for us alone to think about. So we use scale to help us understand that better. So those are the seven cross-cutting concepts, and you're going to see these through so many different areas of science, and it helps us show us how science is connected. It also will help you in the end communicate better and ask questions better to really think like a scientist.